Okay, in this video, we're going to look at how to create vector, parametric, and scalar equations of lines in 3-space. So we've already seen in a prior video how to do it in 2-space. It's exactly the same in 3-space. The only difference in 3-space is that you can actually get another equation called a scalar one, but I'll get to that in a minute. So from the prior video, here is what we're going to use to calculate or to create the vector equation of a line. So I can actually start that right here. Here's 2 points in 3-space. Now again, R naught vector is any point on the line, so I could use either A or B. I'm going to use A, you might have used B, plus the parameter t multiplied by the direction vector. So direction vector, I need 2 vectors and I need to calculate the change in x, y, and z between them. So I'm going to go AB. So the change in x is going to be 3 minus 1, minus 3 minus 2, and 5 minus 4. I think I did that right. So there we go. Exactly the same as we did in 2-space, just that extra z variable to deal with. There's a vector equation. Now let's get the parametric. Let's separate the x coordinates, just like we did in 2-space. Okay, and I think I did that correctly. Okay. So now, okay, let me just label this. This is parametric. Now, when you're in 3-space, now you don't have this in 2-space, but you have it in 3-space, you can create the scalar equation. So just another way of representing the same line. So what we need to do though, we need to go back here to parametric. And what I want you to do is I want you to solve for t. So I'm going to go here. I'm just going to write that down here. Got a little bit more work or room to work. So just solving for t. So we're just going to balance here. And divide by 4. So the first one, x plus 1 over 4. I'm going to highlight that because I'm going to need that in a second. And then we're going to take the second one. So y equals 2 minus 5t. Going to solve for t. I'll highlight that. I need that in a second. And then this one over here. So, oops. So solving for t. There we go. So now, what you're going to do to go to scalar, you're going to take your parametrics, you're going to solve each of those for t. Now they're all equal to t, so if they're all equal to t, they are all equal to each other. So here's how you do your scalar equation. X plus 1 over 4 equals y minus 2 over minus 5 and z minus 4. Now I'm going to put that over 1 because 1's understood there. So now, that is your scalar. You're allowed to do that because they're all equal to t, so they're all equal to each other. Now what I'm going to write here, I'm going to write out the definition of scalar equation. And I'm going to see something neat here. So this ABC at the bottom should be your direction vector. So what do I got here? 4, negative 5, 1. And that was that direction vector. So over here, this x naught, y naught, and z naught should be the point that you use. So let's look over here. So here, now, because it's plus 1, because that was minus x naught, that means that x coordinate is actually negative 1. And y minus 2. So because you got minus 2, that means the y coordinate is 2. Then z minus 4. And we got 4. And that should be that point we use. And yes, it is. Negative 1, 2, 4. So again, same line, but in 3 space you can also represent it in scalar form. Now, I want to show you another example here. So let's take these two vectors. Okay, so I'm going to make my vector equation. So I'm going to choose the first point. Get to choose the second point. So I need that direction vector. So let's go AB. So -1 minus 1 is going to be 0. 2 minus 1 is 1. And 1 minus 0 is 1. Oops, I want to be careful there. Okay, so there's vector. Okay, let's go parametric. So see here, t plus 0 is just 0. So here 1, now t times 1 is just t. And then for z, I got 0, but I do have plus t, so z equals t. So here's a parametric. I should write that vector. Okay, let's take each of these and let's solve for t to get the scalar. Now the first one, x equals -1, there is no t variable. The second one here, well, I can solve for t there. All right, so that's just going to be t equals y minus 1. And the third one, it's already solved for t. So here's where you got to be careful, because not all of them have a t variable, just these two. So you're going to write that like this, y minus 1. I'm going to put that over 1. 1's understood, equals just z. Right? I'm going to put that over 1 because 1's understood. Now, because the x portion of the parametric did not have a t variable, you want to do it like this. You want to put comma, x equals -1. You have to have at least 2 variables of t to make symmetric, which I had here. So this is how I would write it in this case. So if you're wondering, well, okay, how can we tell if I was given this, how to extract the direction vector? Well, remember the direction vector was that A, B, C. I'll just scroll back here at the bottom, right? Well, first thing you notice, there's no x portion, but it's over here, which signifies that means you had division by 0, so x is 0. And then over here, you have your 2, 1, so that definitely checks out. And then for your point, right, the first part you had your x minus x naught, right, up here. So, but here, you already know what x equals. X equals -1, so you can just put -1, y minus y naught, which is 1. And then over here, it's just z, right? So z minus 0 is what's happening there, so that's just 0. Seeing this checks out, this was our direction vector, and this was our point that we used. Okay, so that is how to create the vector parametric